Guys, so today we'll be still continuing with the chapter motion one dimension or motion straight line, and out of this topic we'll be continuing from the live class session, right? In live class session we completed two questions from the chapter or the topic motion of an object which is in downward direction or due to gravity, right? And we dealt with only two questions, right? So a little bit more questions we have to deal with it so that you guys can understand the proper section, and we will try to do maximum types of questions which is usually repeatedly asked in NEET as well as in your school exam questions. Okay, so we'll move on with the problems, right? So we did two questions, means I have to go with the third question, right? So I can hope you guys are seeing the third question here. So you are told that the ball is projected vertically upwards from a tower. Suppose this is a tower. From this tower a ball is projected upwards, and the tower is having a 20-meter height, right? And this ball is thrown up with the velocity of how much? 5 meter per second. So in the direction is upwards, right? The velocity will be plus 5 meter per second of the ball, right? Now find the maximum height which is reached by the ball. That is, once it goes up, it obviously has to come out in this direction and has to reach the ground, but it reaches a maximum height here, right? So it asked what is the maximum height which is reached by the ball. And then second question is time taken or time when it passes from its mean position, right? Or ask what is the time it is going to take to complete the entire procedure. That's the question. Clear? Right? So we'll move on with the solving. Let's take the next page. Let's take the next page, this one. Okay, so I'm going to draw the diagram, guys. This is our tower. Okay, the tower has to be drawn downwards. Okay, this is our tower, right? Let's say this is the maximum height which is attained by the ball, and the ball is thrown up, right? So the velocity is plus 5 meter per second, right? Now what is the height of the tower? 20 meter. So this much is the displacement, right, s of the ball with respect to reach its maximum height. So when it reaches maximum height, then it's continuous to draw downward, right? So at maximum height the velocity would have become 0, right? And after it, see, the ball goes from here, it reaches maximum height, then it comes down, means initially the velocity is positive in this direction, right? So yeah, I'm giving the direction. Then later on, as it reaches the maximum height, the velocity drops, it becomes 0. Then it also increases in the downward direction, but in negative value direction, right? This is something which you have seen in your daily life, right? Once you throw an object upwards, velocity goes on decreasing, but in positive direction. Okay, first it was plus 5, then it becomes plus 4, plus 3, like that, and at some point the velocity will reach 0. That is the point where the maximum height is achieved. Okay, so you have plus 5 meter per second. Now what will be g? Minus 10, right? Because gravity, acceleration due to gravity is downward, meter per second square. And what is v? 0 at maximum height. This displacement I am to find. So we'll read v squared minus u squared is equal to 2as. Substitute the value for a, this one, minus 10. As I have to find, you have the value of u as plus 5 and you have the value of v as 0. So after calculation you will get s is equal to 1.25 meter, right? That is from the top of the tower, this much distance is 1.25 meter, right? That means from ground, what is the distance? Ground, this is 20 meter, right? So from the ground the ball is at a height of 20 plus 1.25, which is 21.25. oh, I don't know why it is coming up. 21.25 meters is the height the ball is achieving when compared from the ground level. This much clear? Easy, right? Now we are going for the next part, guys, right? Now again I'm going to draw the same diagram. This is our tower. Velocity is plus 5 meter per second. right? Let's say this is our mean position, right? You're asked the time to cross over for the mean position, right? So what is v is equal to u plus 80. Now once the maximum height is achieved, right, the ball reaches here and then it comes downward, right? So while system velocity will be 0, velocity u is 5, this is g t. So I'll get t is equal to around 0.5 second. That means the ball has now reached this maximum point height by a time interval of 0.5 seconds, right? If clear, so that means from, suppose if I take this, I'm just going to consider the mean level, guys. So this is a tower's top side, okay? From this position to this position, from here to here, from this point to this point, the stone is taking 0.5 seconds. That is the meaning of this derivation, right? To achieve the maximum height, it is taking 0.5 seconds. Then obviously from here to here also the time period will be 0.5 seconds. Equal displacement, right? This much height is having 0.5 seconds. Then this is also 0.5 seconds. Right, so this is a mean position, right? So if this is 0.5 second, this is also 0.5 seconds. So from this point, let's say A, to this point B, what is the time period taken? 1 second, right? So time when the stone will pass from its mean position, this is how much? 1 second. This is the mean position. Clear? Easy. Now this entire process could have been solved by a very simple process for the second question part, okay? How? See, let's consider just the tower case, okay? Let's move downward. When I just above second part of the question, that is B part of finding the time for passing the mean point, can be solved by a simple section. We have to understand the logic. So this is our tower. So this is our initial position A and this is our mean position, right? So you are asked what is the time for reaching from A to B. That is our question, right? Say, but the perspective of ball or the stone, right? See, you are having the position change in only x coordinate. This is y coordinate, right? Oh, sorry. This is our y coordinate, right? In perspective of stone which is thrown up, right? So the displacement with respect to, or when we talk about stone, is in which direction? In y direction, right? We are not giving, we are throwing the stone up, so we are giving the displacement in y direction, not in x. Or even if there is a displacement in x, that is not which is given priority, right? We are giving displacement for the stone in which direction? In y direction. The stone goes up and it comes back, right? So in perspective of, in the, if we say just in the coordinate of y coordinate was initially, let's say this was 0, then this coordinate of y is also 0, right? So displacement in y direction is 0, right? So displacement S, right? Let's say Sy is equal to Uy, that is velocity in the y direction, plus half Ay, that is acceleration in y direction, into t square, right? What is displacement in y direction? It is 0, right? The ball is reaching A and then it is reaching B. What is velocity in y direction? That is the velocity by which it was thrown up. It is 5t, right? Then what is minus 1 by 2? G is in y direction, right? T squared g, you can put 10, you will get the t value as 1 second directly, right? So initial procedure was also correct, but it is time consuming. This is something which takes least amount of time. I hope this much is clear, right? So now we'll go with the next problem. Okay, so what is the fourth question? A ball is projected, right, and vertically upwards from a tower of height 20 meter at a speed of 5 meter per second, right? And find the speed of the ball just before hitting the ground. That is when the ground, the ball reaches the ground, what will be its velocity, and find the time taken by the ball to reach the ground. Simple. So we'll solve the question. how will we approach the question? So we'll draw the diagram just like the previous cases. This is our tower. We are having a ball. It is to be thrown up. Will be plus 5 meter per second. Thrown up means after some time will reach ground, right? The tower is 20 meter height, right? So this is its initial position. This is its final position. Simple, right? So U is plus 5 meter per second. A is minus G, that is minus 10 meter per second square. It is downward, right? So displacement, tell me, what would be the displacement? This is its initial position. This is its final position, means in the case of y direction, guys, you remember when you are throwing up or down, the displacement you are supposed to take in which direction? Y direction. So here the displacement as per the diagram, see, initial, final and initial displacement is 20. And the displacement in downward direction means S will be minus 20 meter, right? So V squared minus U squared is equal to 2AS. Now put the values. What will be V? That is what is asked. What will be the final velocity or the speed before it hits the ground? Is equal to U squared, right? That is 5 squared, right? Plus 2 into A is minus G, that is minus 10. S displacement minus 20. You will get the answer of around V will be equal to, let's say, I'm sorry, it will be 425 meter. So V will be equal to root of 425 meter. I'm not getting, or not meter per second velocity, right? So I'm not finding the root. It is something which I put the question for you guys to understand. The numbers will be proper in the case of your exam point of view. That is, the proper numbers, numerical numbers would be given to you guys, so that it will not give a complicated answer like what I found, right? Let's move on. Part of the question, right? What has been asked? What is the find, or if I were asked, find the time taken to reach the ground. I'm sorry guys, my dog is barking like anything. Sorry, can't do anything about it. Okay, so this is our 20 meter height tower. So this is, let's say this is the initial position A. From here we have thrown the ball upwards with velocity U plus 5 meter per second, reaches maximum height, reach the ground, right? So that means what is the displacement of the ball? You know, that will be S is equal to minus 20 meter, right? Initial and final position are this one. So this is the displacement of the ball or the stone, just minus 20 meter. Now from the ball to reach from here to here, that is the maximum height or change. The time is U by G, right? This is ascending time, then descending time. So that this is the mean position and this is B, right? So A to B will be, if the time of ascending is U by G, time of descending is also U by G. The total time will be what? 2U by G, right? So for time for stone from reaching from A to B will be 2 into 5 divided by 10. It will be 1 second, right? You just calculate it, right? So it reaches from A to B in 1 second. This much clear, right? Now displacement again. I can find the time for reaching the ground. From here to here, you require, or you find the answer 1 second, right? Now you require the ball from reaching from here to here. So what will be the displacement? Again it will be minus 20. I told you again. Velocity. Now see guys, from here to here the direction of velocity U was plus, right? Now it reaches velocity 0 at the mean position. Then when it comes down, the velocity goes on becoming negative, so that at last position the velocity would have become what? Some values, right? But I can say, from, if this is plus 5 meter per second at A, at B it will be minus 5 meter per second. Remember, right? If the velocity is plus 5 meter per second in A, then the same position B will be having velocity minus 5 meter per second. So I am going to go for the scenario for this displacement. So initial velocity at this point is minus 5 meter per second. Now put the values. S is equal to ut plus half ut squared. S is minus 20. U is minus 5t, right? Plus half minus 10t t square. Find the value of t, guys. Right. Now what you find the t, right, that is for the time for the stone from reaching here to here. That should be added with the 1 second. Then you can say the time taken by the stone to reach the ground. That is your homework. Try to do it by yourself. Find this t. You will get a quadratic equation by solving this one. Okay. Simple. Right. Now let's move on with the next question, which is fifth question. Should I enlarge it? Can I enlarge it? Oh no. Can I enlarge it? Okay. So this is my fifth question. A ball is thrown upwards at the speed of 28 meter per second, and you are asked what is the speed of the ball 1 second before reaching its maximum height. Right. So moving on with solving. Okay, it's as you can see this question is very small, right? So you are having ground, you are throwing a ball from here, it reaches maximum point, then it comes back to ground. So 1 second before, right, 1 second before it falls, that's the question, right? Let's repeat the question. Find the speed of the ball 1 second before reaching the maximum height, right? So if it is reaching this point, right, so 1 second before it falls means this is 1 second before, right? So you are asked what is the velocity at this point, right? Clear? Right. Now when I throw a ball like this with the velocity you are given 28 meter per second, right? So it is thrown up means u will be plus 28 meter per second. At maximum height v is equal to 0, or I can just find what is the time of ascent. It will be u by g, right? U by g is 28 by 10. It will be 2.8 second, right? So 2 point to the ground is also 2.8 second, right? Ascent and descent time period is same. So that means if this is 2.8 second, so 1 second before means this from here to here it would have been 1.8 second, and this will be 1 second, right? So you are asked what is the velocity at this point, right? 1 second before 2.8 second will be this duration from ground will be 1.8 second, right? 1 second before 2.8. See, this is 10 o'clock, I reach a place at 10:30. 5 minutes before 10:30 will be 10:25. I have to get from behind, right? Like this 5 minutes will be subtracted from here, right? That's meaning. So it is 2.8 second means 1 second before means from here, right? 1.8 second, and this will be 1 second. Clear? This is 1 second I meant. Clear? This okay. This not clear means I will write it with another color, guys, because all are black. So this is 1.8 second. This is interval 1 second, because 1.8 plus 1 only becomes 2.8. So 2.8 seconds before that 1 second means the time interval velocity is asked at this point. Clear? So what velocity equations I have to use? How can I solve that? Now you have got a picture, right? Now at that point velocity is 28 meter per second, right? Throwing up, right? Now acceleration is minus 10 meter per second squared. T is 1.8 second. Now what is V? Is equal to U plus 80. That is 28 minus 10. Put 1.8. You can find the corresponding answer. Right, around will be what? 28 minus 18, right? You will get around 10 meters. Clear? Not meters, 10 meter per second. So the velocity just 1 second before the reaches ground, velocity at that point, let's say velocity at this point is 10 meter per second. Clear? Right? And move on with the next question, guys. Oh, where is that picture? To bring it this side, I'm sorry. Okay, it doesn't become large. Okay, we are having the sixth question. A tap drops water at 1 second interval. Find the distance between third and the fifth drop when the sixth drop is coming out of the tap, right? So
How will we solve that question, guys?
So let's consider, okay, I didn't take the pen. Okay, this is our tap. So the sixth drop is just coming out. So this is our sixth drop. Let's say this is fifth, this is fourth, this is third. Okay, so each drop is having an interval of 1 second means, so the fifth drop would have come 1 second before sixth, fourth drop would have come 1 second before fifth, and third would have come 1 second before fourth drop, right? That means the third drop had been coming, or the interval of the third drop is 3 seconds. See, 1 1 1. So this, the third drop has come around 3 seconds before the sixth drop. We are considering the sixth drop as our origin, right? So 0, right? So, or I can say the fifth drop has come 1 second before the sixth drop, right? So the time interval of, let's say, the fifth drop is 1 second. The third drop is come 3 seconds before the sixth drop. So its time period is 3 seconds, right? So let's consider each drop separately. So let's consider the third drop, right? It is coming dropping, right? Dropping object means its initial velocity is 0. Acceleration will be due to gravity, which is minus 10 meter per second square, right? And what is time period? Its time is 3 seconds, right? Because it has come, we are comparing with the sixth. Okay, I don't know why the different colors are coming up. Okay, so the 3 seconds, right? I'm taking because we are taking the sixth drop as origin. It is just coming out, right? Clear? So this much parameters have been given means I can definitely find s, which is ut plus half gt squared. Put the value of u, g, then you can t, you can find the displacement. I have already calculated. You will get around 45 meter. Try to solve it by yourself, guys. Right? I am going to say this displacement, this is of third drop, right? Let's name it as h3. So this is our h3, right? So fifth droplet's displacement is h5. Okay, you are asked what is the displacement between the third and the fifth droplet, right? So this is the displacement you are asked. That is h5 minus h3 minus h5, right? Because the third drop would have traveled a lot, right? Clear? So I now have to consider what? Fifth drop also. Now let's talk about fifth drop. Now how can I calculate for fifth drop? Again, time period is 1 second, right? Of 1 second before the sixth drop it is coming out, right? Its initial velocity will be equal to 0, and its g, or acceleration, will be also equal to minus 10. Let's take it as minus 10. It's fun. Now s is equal to ut plus half gt squared. Put the values like that. T will be 1. This is very easy. You will get the s as minus 5 meter, right? Korea. The other one will be minus 45. I'm sorry, I didn't write the point. It means minus because it is coming down, right? So you have this, let's say it is h5, right? So what is h5 minus h3? 45 minus 5, right? It was 40 meter, right? So 40 meter is the difference of height difference between the fifth drop and the third drop. Easy, right? It's not that tough, right? Now we will go for the next question. After this question, you have to talk about a little bit theory section. I left off a small equation, right? If possible, we'll solve it, okay? Or I will tell you. The next question is a balloon, right? A balloon rises upwards with a speed of 10 meter per second. When the balloon is at the height of 100 meter above the ground, a stone is dropped from it. Find the time taken by the stone to reach the ground. This is much easiest section. Maximum height reached by the stone, and find the distance between the stone and the balloon after 3 seconds, right? So let's solve it. So a balloon is there, right? I don't know why it is not getting selected. Okay, so let's say this is my balloon, this is my stone, right? Now the stone is getting dropped, right? Now this position is 100 meter above from the ground, right? Okay, now this balloon is moving up with a velocity 10 meter per second. If the stone is dropped from the balloon, then the stone would have been also having its initial velocity 10 meter per second upwards, right? Inertia, you have learned about it, right? And what would the displacement if the stone comes from here? Obviously, last position is till the ground, right? So the displacement will be this much height only, right? So the displacement is minus 100 meter. U is upwards, right? So it is 10 plus 10 meter per second. What is A? Minus G. It is minus 10 meter per second squared. So you can definitely find the value of T. How? S is equal to UT plus half GT squared. Put the values, guys. Find the value of time. I have not find the time. Value you guys can find. You will get the value of time because other parameters are given. You get a quadratic equation. Find the value of T. I think it will be in the root format. Clear? Now that is the first section's answer. Find the time taken by the stone to reach the ground. Now what was the second question? Second question was maximum height which is attained by the stone. Maximum height means I have to bring the bracket out. Okay, this is our stone, right? Okay, the stone was having a velocity 10 meter per second. It goes up and it reaches a maximum height here. At that point velocity is 0, right? Remember, so you are asked this displacement maximum, right? What is A? Minus 10 meter per second square, right? So V squared minus U squared is equal to 2AS, right? You have other parameters. Obviously you can find the value of S, right? What is V? It is 0. What is U? 10 squared 2 minus 10. You can find the value of S. This one, maximum height can be found. You will find the value as around 5 meter, right? So that means the ball, I'm going back with the previous figure, guys, right? The ball from here to here is how much? 5 meter. So from the ground, what will be the total distance? 100 plus 5 would be 105 meter, right? So the ground is at a distance of 105 meter from the, or the ball is at a distance of 105 meter from the ground. Clear? Now let's move on to the third part of the question, which is find the distance between the stone and the balloon after 3 seconds. Right, this is something which you have not done. So let's say this is the mean position of the stone only and this was the balloon. Right, let's say the balloon is moving with a uniform velocity upward. Right, nothing has been mentioned about the friction, etc. Right, so the ball would have moved like this and it would have reached the ground, let's say this. Right, so this is the mean position. Right, so the displacement, right? So after 3 seconds, where the stone will be, I can say S is equal to UT plus half AT square. Here T I can put 3. U is 10, right? So you will find this U is 10. 3 plus half G's value minus 10. Then put 3 square. You will find the S value as minus 15. That is, if this is the initial position of the stone and this is the final position of the stone, the displacement of the stone after 3 seconds, right? After 3 seconds, the stone would have had a displacement of minus 15 meters. So what is the displacement as per the figure? This will be the displacement, minus 15 meter. Right? That is what this means. After 3 seconds, the stone would have reached, I don't know if it is the ground, this might be the ground, right? It would need not reach the ground. So it reaches a position, say B, right? And that B position's displacement from A is minus 15 meter, right? Clear? Right. Now moving on. Now that is the ball has reached up to a certain below and the displacement from initial position is minus 15 meter. But in 3 seconds, the balloon should have moved. How much would the balloon move? It is having constant velocity, right? Nothing has been mentioned regarding the balloon. So the balloon would have moved how much? Distance is equal to velocity into time. Its velocity is 10 meter per second. In 3 seconds, it would have traveled 30 meter, right? So previous diagram itself, the balloon would have reached here and this is its initial position, right? So this would have been 30 meter, sorry, and this is now the position of stone. So this is 15, right? So what is the displacement between the balloon and the stone now it is 30 plus 15, that is 45 meter. Clear?